My name is David Retorno, technical manager of this company, and it's a pleasure for me to introduce you this company. Picta is a family company founded in 1964 and is dedicated to the processes of extrusion, printing, converting of plastic bags, security envelopes, automatic packaging film, etc. It is made for of a permanent staff of 170 people, and our turnover is approximately 35 million. Now we are focused in improving production processes and quality control. Our last bet is RFID technology. We are very confident that this technology will help to the company in its future. Thank you very much.
The technology we develop is as following: data modeling and information systems, technology system integration, application of ASP.NET technology and XML to different business models, development of e-business solutions for both desktop and web, development of training courses, and development solutions for e-business. We also specialize in web development, e-commerce, data modeling, business process modeling, and system integrations. Our main role in the project is the project coordination of the test pilots in Spain. In particular, the group will implement, deploy, and support the pilot deployment for Picta. Our expected benefits are to demonstrate to the Spanish industry the benefits of using RFID tags in terms of improving competitiveness and management cost through the test pilot programming in this project.
Our client Picta is a plastic bags producer interested in improving product manipulation and warehouse processes, detected as a key factor to improve productivity. RFID technology seems to provide a set of features applicable to this matter, and this pilot explores and exploits that set of RFID characteristics in order to get the expected benefits in warehouse operation. The pilot tried to demonstrate the capability of RFID technology to improve productivity and performance of the organization as a whole, improve the standardization of the quality of plastic bags for each sales order and the number of brown lots sent to clients, improve and accomplish service deadlines, reduce production cost in general and manipulation cost in particular, and finally, to improve the energetic efficiency in the plastic bag production process. What are the problems that have led us to identify product manipulation as a key factor? Well, the fact is that it's quite easy to take and use the brown coil, which implies additional consumption of raw materials, more production effort, non-standardized quality of bags, longer times of service, additional waste material, and even increase the consumption of energy. Another problem is the location of coils, which makes forklift drivers lost a lot of time searching them along the warehouse. The solution to all that problems is quite simple. Automating on-plant product manipulation will eliminate mistakes and time-lasting location of coils. RFID technology is the better way for automating operation in the warehouse and so to reach the goals mentioned before. Finally, getting track of all warehouse movements, we get an additional benefit derived from traceability information, which permits detection of defective or lots of coils, identification of wrong manipulation, or even malfunctioning machines. Getting such a log of what has been done, what coils were used, when was it done, and who did it, give management a powerful tool to detect and prevent the source of problems.
Following, we will present the technology deployed in PICDA, but in order to understand the work done in the pilot, we present it in the context of the whole production and serving process. Let's see it. Well, as PICDA fabrication process follows an on-demand approach, every production process begins with a sales order. Sales department transforms client needs into general design and logistics specifications, indicating, for example, strength, material density, kind of bag, colors, pictures, text, barcodes, units per package, and so on. But client order is not complete until technical data for extrusion, printing, and tailoring processes are inputted. So, production department takes control and complete the client order with valuable information needed. For example, to standardize the quality of bags with the same requirements of strength. This is a major concerning issue, and providing technical standardized info such as machine adjustment parameters attached to the order is the only way to get it. Once the client order is completed, it is transformed into production orders either directly from lines of the client order or by consolidating or splitting orders. Then, the production manager can prioritize orders by using consulting, filtering, and ordering tools. And, of course, assign it to machines and launch the orders. Production manager can also track orders, which in turn implies fulfillment of quality forms and acquisition of oil and action traceability information. The fabrication process itself requires of on-plant operation and implies passing through the extrusion, printing, tailoring, and servicing processes. The process reproduced here corresponds to the printing process, considering that extrusion and tailoring processes works in a similar manner. Before seeing the process working, let's take a look to the forklift equipment. Every forklift is equipped with two antennas and a rack computer. The first antenna, the lateral one, is used to detect different warehouse zones. The rack computer provides information to the driver of what order, what coil should be taken, where is it located, and where must be left. Finally, the frontal antenna is used for shelf and product detection. The system shows the forklift driver where is the coil he has to pick up and what is the destination machine. When he approaches the rack, RFID readers start working. As every coil and every rack hole is equipped with a RFID tag, when the forklift approaches to them, the frontal antenna starts reading and register both IDs. Everything is okay, for example, the forklift has taken the right coil, the system registers the movement and that's all. If there's a mistake, the system informs the driver, who in turn takes the corresponding correcting action. Video shows a typical mistake and its correction. Once printed coils are finished, they are taken and driven to the waiting point. At the waiting point, there is a waiting station. The waiting station is the central operation point. Every coil visits this point just after its, we can say, creation, or when it is transformed into another smaller coil. Every plant waiting station consists of the following elements: an LF reader needed to authenticate the person who is going to operate the computer, and a UHF reader used to read product tags and to write new position tags if necessary. A computer to run the plant production application. And an RFID printer that print and save the information in the product tags. The process of wearing a coil is not only wearing by itself, but creating a new article and give traceability to its parents. The process is as follows. The driver tracks the forklift and presents its credentials to the waiting station system, recorded in a proximity card. The system authenticates him or her and starts the session. Then the driver selects the corresponding production order and weighs the coil. And next, the RFID tag and a coil form with visual information for human are printed and the coil is labeled with them. Finally, the printed tag is related to its parent tag and the quality form is filled in. System keeps tracking of all these relations in order to give traceability in case of a defective lot. Once weighted, printed coils are typically stored. It doesn't matter where to locate a coil. The system keeps track of all movements and of course of its new allocation. The process is as follows. The forklift takes the coil from the waiting station and then the frontal reader informs of it to the system. Then the new state is charged or loaded. When the forklift is leaving the coil in the rack, notices a variation in the intensity of the product signal, the system reads its new position. The new state is then unloaded. And finally, when the product signal is definitively lost, the system registers the movement. The new state is then unloaded. In conclusion, we consider RFID technology as a cornerstone of warehouse automation, especially when robots cannot be used, and a key factor for giving traceability along the whole production chain, from the very beginning to the final consumer. In the next years, PICDA plans to automate warehouse exits, automate another warehouse they have in the same camp, and start using EPC identification numbers to share information with its partners. Finally, Alu Group, hand by hand with STIC, is doing a hard job informing other companies intensives in warehouse operation of the RFID potential to improve warehouse and production processes, and finally to reduce costs and help accomplish service deadlines.